We're going to continue our review for our Chapter P test. We have two questions we're going to look at today, some of the more difficult ones from the second half here. The first one, you are asked to divide two rational expressions. In order to do that, we want to think of them in their factored form, and we also have to remember that when we are dividing, we're actually going to multiply by the reciprocal. So let's go ahead and factor all of this. X squared plus 7x plus 12 would factor into x plus 3 and x plus 4. Our denominator here, x squared minus 2x minus 15, we can factor that one. To get a negative 15, we could use a negative 5 and a positive 3, and those add up to our negative 2 in the middle. I'm going to go ahead and flip this over as I factor it. So now I'm going to factor this, x squared minus 3x minus 10. We look for two numbers that multiply to be negative 10 and add up to negative 3. So we'd have negative 5 and positive 2. This now is going to turn into our denominator. It is not a typical trinomial, so we look at that there's a common x that we can factor out. So that's that Gcf factoring. We'd have an x plus 4 as our second factor. Now everything is in factored form. Before we start crossing anything out, we want to look at our restrictions. All right, so domain restrictions, what can x not equal? So things that would make our denominator 0. So our first one here, x minus 5, we know x cannot be a positive 5. For this one, x plus 3, x cannot be a negative 3. It would make that 0. Here we know that x cannot equal a 0. This would become 0 if x was negative 4, so we have to restrict that. And then remember with division, we also have to look at our numerator here because it was initially a denominator. So again, looking at x minus 5, we already have that x can't be a 5. For our x plus 2, we have to state that x cannot equal negative 2. So we have quite a few restrictions on our variable. Our next step, so we factored everything. We looked for domain restrictions. Our last step is to look at common factors that we can divide out. I do see an x minus 5, one in the numerator, one in the denominator that we can cancel. We have an x plus 3 that we could cancel out. We have an x plus 4. And so our final answer, the only thing we have left would be an x plus 2 divided by an x. And remember, that's all we can do to simplify that. We cannot take those x's out, because you have to think of this as one whole number. The x plus 2 is one single number. The last example that we were going to look at today to review for our test is how to simplify a complex fraction like this. And we had a couple different methods, but when I look at this one, at all the denominators, I have an x plus 2, I have an x minus 5. This is the same as what I've already talked about. I've got a same here, x plus 2 that I already had, and I have a 1 here. So I really have a lot of overlap in terms of the denominator pieces. So I'm going to go ahead and multiply by our least common denominator. In this case, our LCD, our common denominator, would be an x plus 2 and an x minus 5. And remember that we are multiplying that to all of the numerator and all of the denominator of this big complex expression. All right, so what happens when we multiply it to our first term? So I'm going to take these two and multiply it to here. Since I have the same two factors in the denominator, they would cancel out. It leaves me just with a 5. When I multiply it to this one, the x minus 5 factor is going to drop out because I have one in the top in the numerator and one in the denominator. But I am left with the 2 and this x plus 2. Okay? When I look at the denominator, distributing to my first term, the x plus 2's are going to cancel. I'm left with a 3 and an x minus 5 term. And when I multiply it to this last one, there's nothing that's going to cancel out because I have just a plain 1 under there as the denominator, under the 4, so nothing is going to drop out. I need the 4, I need the x plus 2, and I need the x minus 5. All right, so we are cleaning it up. We've simplified it down now so we don't have all those little mini fractions. Let's go ahead and see what we have for our numerator. We're going to distribute a negative 2 in here, so we have 5 minus a 2x minus a 4. For our denominator, distributing, we've got a 3x, we've got a negative 15, and for this last part here, let's go ahead and FOIL this x plus 2 and x minus 5. So we'd have x squared minus 3x minus 10. I'm going to multiply 4 to that, so I've got 4x squared. I have a negative 12x and a negative 40. Combining like terms, for our numerator, we would have a negative 2x plus a 1. For our denominator, we have a 4x squared. We have a 3x minus 12x, that would be negative 9x. And we have a negative 15 and a negative 40, so we'd have negative 55. Domain restrictions for this one. Let's go back and look at our initial problem. For this first factor, x plus 2, we know that x can't be a negative 2. For our second factor, x minus 5, we know that x can't be a 5. The other denominators are just repeats of what we've already looked at. Now I look at my final denominator. Let's see if we can get this factored down. Our 4x squared minus 9x minus 55. That does factor. 4x squared, we could do 4x and x. We could also do 2x and 2x. We could try that if this doesn't work. For 55, I'm going to think of it as 5 and 11. Checking, we've got 11x minus 20x. That would be our negative 9x. So it does factor down, which allows us to figure out those domain restrictions a little easier. 4x plus 11, we don't want it to be 0. So x cannot equal negative 11/4. So we're going to add that to our domain restriction. The other one is x minus 5. We already had. We said x couldn't be a 5. So our domain restrictions would be negative 2, 5, and negative 11/4. All right, you guys are going to finish up your chapter review packet. Let me know if you have questions.